Okay, here's our last video in section 4.3 on adding and subtracting polynomials. We're going to do our last example here, a little bit of application where how can we possibly use these polynomials, something with multiple terms and variables in it, in real world. So looking at example number 10, it says here we have a 16-foot wide round fountain is built in a square city park that measures x feet by x feet. Find a polynomial for the remaining area of the park. So I don't know about you, but it always helps me kind of draw a picture to kind of visualize what's happening. So it says here that we have a square park. We're not really sure what the measurements are, but it's a certain feet by a certain feet. And so I'm going to draw a picture of that. And then I know inside the park, there is a round fountain that is 16 feet wide. And so I don't know about you, but this is kind of what my park looked like. It's asking us to find a polynomial that represents the remaining area of the park. So what we really want to do is we want to figure out the area of the whole entire park, the square, and we want to subtract out the area of that fountain so that we could just find the rest of the area of the park. So if you were like going to put grass down, right? And so translating it, we have the area of the whole entire park minus the area of the fountain. Well, the area of the whole park would be the area of a square or a rectangle, which we know is base times height, or in this case, x times x. We also want to subtract out the area of the fountain, which is a circle, and we know that the area of a circle is pi r squared. So in our picture, we have the area of our square as x times x, and then we're going to subtract out the area of our fountain. Well, we know if the fountain is 16 feet wide, that's the diameter, which means the radius of my fountain should be 8 feet, right? And so I plugged in my 8. I simplified it a little bit, and so I have the area of the remaining part of the park as x squared minus 64 pi. And that's area, so it would be in feet squared. Okay? Can't really simplify it anymore, and so there's our polynomial that represents the area of the remaining part of the park. You try some of these problems. So pause the video, try it number 1 and try it number 2, and see if you can add and subtract these two polynomials. And then come back and see if you got the same thing I did. All right, for the first one, remember we always want to distribute to get rid of the parentheses. So in this first one, I'm going to distribute a positive 1 and a positive 1 to both sets of parentheses. I end up with a whole bunch of different terms, and now I should be able to combine like terms. Writing my polynomial in standard form, I'm going to start with my t cubed first. So I have a 6t cubed minus 4t cubed. That gave me a 2t cubed. I have a negative 5t squared and a 6t squared. That leaves me with a positive 1t squared. I have a 4t plus a 1t, that's a 5t. And then I have a 7 plus 2 is 9. So my final answer is 2t cubed plus t squared plus 5t plus 9. Hopefully you got the same thing as me. All right, look at number 2. Number 2 is a little bit different because now it's asking us to take these two polynomials and subtract them. We want to follow the same process, so make sure that you take the number in front of your parentheses and distribute. So in the first set of parentheses, I'm going to distribute a positive 1. Now in the second set of parentheses, I'm going to distribute a negative 1. And so your signs for all of your terms in the second set of parentheses should change. So I got an a squared minus 3a minus 2 minus a 2a squared plus a 6a plus 2. And then I'm going to combine my like terms. I got a final answer of negative a squared or negative 1a squared plus 3a. Hopefully you got the same thing as me. All right, that concludes 4.4. Make sure that you practice by doing your homework and let me know if you guys have any questions.